Bismillahirrahmanirrahim. So in the video we are going to show the example for chapter 3 AC drive. So we start with example 3 by adding rotor resistance. So remember we have a few methods for controlling speed of induction motor. One of the method is adding rotor resistance, meaning that we add resistor in the rotor side. So let's read the question first. The rotor of 10 pole 50 Hz 3-phase induction motor has a resistance of 0.25 ohm per phase, and runs at 500 rpm. If the load torque remain unchanged, calculate the additional rotor resistance that will reduce its speed to 90% of its rated speed. Neglect stator impedance. So in this question we have to neglect the stator impedance, which is R1 and X1. And also not given in the question is X2. So the only resistance that given is the rotor resistance, which is R'2. So given P is the number of poles, which is 10, frequency is 50 Hz, and then R'2 is 0.25. So this is ohm per phase, and then the speed of rotor resistance is 500. The speed of rotor is 500 rpm. 500 rpm, and then the R2 is the required speed. R2 is the required speed, which is we have to reduce by 90%. So if we reduce 90%, the remaining speed is 10%. 10% multiplied by 500 rpm. So it will be equal to not 10%. So the question mentioned that reduce its speed to 90%, bukan reduce by 90%. So reduce to 90%. So 90% multiplied by 500, which is 450 rpm. So this is the required speed, and then we have to find the additional rotor resistance in order to reduce the speed by 450 rpm. And then the other information is the load torque remain unchanged. So meaning that T1 equals to T2. So firstly we have to analyze during normal condition, which is we have to determine NS 120F over P. So 120F is 50 over P. So P equals to 10. So NS is equals to 600 rpm. And then NS to determine S1, which is slip at normal condition, 600 minus NR is 500. The rotor speed divided by 600. So you will get 0.167. And then NR2 is this one 90% from 500, which is 450 rpm. So we can determine S2, slip during this condition at speed 450 rpm. So remember NS is remain unchanged because of NS is depends on frequency and number of poles. So the frequency and number of poles is not changed. So NS is 600 minus 450 divided by 600. So you will get S2 is 0.25. So we want to determine the additional resistance. So if I can draw, for example, at load side, the connection is star. So this is R'2. So we want to determine additional resistance R at which is in series with R'2. So let, okay, so we assume this one is R prime or R2 new. Okay, R prime 2 new lah. So R prime 2 new is equals to R prime 2 plus R add. Okay, which is R prime 2 given is 0.25. Alright, so and then we will determine this R add by using, okay, T1 equals to T2. So torque at condition 1 equals to torque at condition 2. So 3V phase squared over S1 omega S, and then so on. Okay, so we know that 3V phase squared, okay, is similar during T1 and T2. So the value is similar, so we can cancel out, okay, with this side. Same goes with omega S, okay, because of NS is remain unchanged, so omega S is similar. And then R1 is not given, X1 and X2 is not given, so we neglect. Okay, this R1 is not given, X1 and plus X2 is not given. Okay, so what is remaining in this equation? Okay, so this one is R prime 2 over S1. Okay, multiply with this one, 1 over R prime 2 over S1 squared. Okay, and then on this side is R new over S2. Okay, multiply with 1 over R new over S2 squared. Okay, so this one is similar, so we can cancel out. Cancel out. So the remaining is, this is 1 over R prime 2 over S1. So dia akan jadi this one lah, S1 over R prime 2 equals to S2 over R new. So you can determine R new, okay, by insert all these value we already known. So S1 is 0.67, okay, over R prime 2 is 0.25 equals to S2 is 0.25 over R new. Okay, over R new. So R new we will get equals to 0.374. Okay, 0.374. So based on, okay, based on this equation, okay, we can determine R add. So R add equals to R new minus R prime 2, which is will be equals to 0.12524 ohm. Alright. Okay, so we continue with example 4. Okay, actually you can read the question first. So I will giving the step to solve this example. Okay, so what we want to determine is what is the additional resistance in order to obtain speed of 900 to 925 rpm. Okay, so we want to determine R at in series with, okay, R prime 2. So in order to determine R at, so we have to, okay, like the example before, okay, R prime 2 new, okay, equals to R prime 2 plus R at. Okay, so let this equation, so we know this one, and then we can determine R prime 2. So how to determine R prime 2 is based on T2. Okay, torque to T2 equals to 3, okay, V phase squared over S2 omega S, okay, multiply by R prime 2 new, okay, divide by R1 plus R prime 2 new, okay, over S2 squared. This is equation for torque, S1 plus X2 squared. Okay, so from this one we can determine R prime 2 new. So how to determine T2? Okay, how to determine the T2? So because of all these parameter, we can determine from the equation V single phase, S2 omega S, okay, and then all the parameter, okay, if the equation given, you can insert in the equation. Okay, for T2, how we determine T2 is based on T2 equals to Kn squared, Kn N2 squared. So this is rotor speed 925 rpm. Okay, so this equation is given in the equation. The equation is given this one, T equals to Kn squared. Okay, the equation for torque. So to determine T2, we have to use this equation. So to use this equation, we have to determine K. K is the constant. Constant. Okay, how to determine K? Okay, by using the similar equation. Okay, K is determined by using T1 and N1. So if we arrange this equation, okay, K equals to T1 over N1 squared. Okay, T1 over N1 squared. So okay, firstly you have to determine T1. So T1, okay, the similar equation for this one, but the S is S1. Okay, T1 equals to 3 V phase, okay, 3 V phase squared over S1 omega S. Okay, this is R prime 2, so not R prime 2 new. So this one is R1 plus R prime 2 over S1 squared, okay, plus with X1 plus X2 squared. Okay, so if you get the T1, okay, torque at normal condition, okay, you can determine K by using T equals to K and 1 squared. So this equation is given in the equation. Okay, if you get the K, you can determine T2. If you get T2, okay, you can determine R prime 2 new. So by knowing the R prime 2 new, you can determine R at, okay, which is the main equation, okay, for this example. Right. Okay, so let's determine the at normal condition. So we can start with NS. So NS is by using 120 F over P. Okay, so you can calculate, and then the answer is 1000 rpm. Okay, and then S, okay, is equals to 0.05. Okay, it's given in the equation, which is 5%. Okay, the S at normal condition is 5% and equals to 0.05. Okay, and then from this S and NS, we can determine NR. Because of NR is not given in the equation. Okay, the normal speed, okay, the rotor at normal speed. Okay, by using actually S equals to NS minus NR over NS. So if you rearrange the equation, you can determine NR. NR equals to NS 1 minus S, okay, which is equals to 950 rpm. Okay, so let's determine torque at 950 rpm, which is T1. Okay, you can use this equation. Okay, T1 equals to or this one lah. Okay, yang mana yang tak bagi, you can neglect it. Okay, for example R1, X1, so semua boleh neglected. Okay, and then the answer is, okay, the answer is 386.97 Newton meter. Okay, from this one you can determine K. Okay, the K is the constant. Okay, T1 equals to K N1 squared, which is given in the equation. Okay, so K you can determine. So the answer is 0.428, okay, multiplied by 10 to the power of negative 3. Okay, so from this K you can determine T2. Okay, T2 equals to K N2 squared. So N2 is given by 925 rpm. So this is required, okay, rpm given in the equation. So K we determine from this one, and then we can determine T2. So the T2 is 366.87. Okay, and then after you get the T2, you can determine. Okay, so the next step is we want to determine R prime 2 new. Okay, by using this equation lah. Okay, 3V phase squared. Okay, 3V phase squared S2 omega S R prime 2 new, blah blah blah, semua ni lah. Right, so what I want to show to you is, Okay, some of the parameter we can neglect it because of is too small. Okay, so if dah masukkan equation, okay, 360 and then this one, okay, and this side you can ignore. Okay, you can ignore 0.075, okay, because of is too small. Okay, and then finally you can rewrite the equation. Okay, so r prime 2 new, okay, equals to 0.075 squared, okay, over 0.0167. Okay, so the answer for r prime 2 new is 0.34. Okay, so we can determine r at. Okay, we know that r at equals to r prime 2 new minus r prime 2. So we can get 0.14 ohm. Okay, so this is okay, because of we know that, okay, when we do this analysis, okay, all the parameter, okay, is we mention here referred to stator. The parameter in this equation is referred to stator, but we want to add our resistor, okay, in series with the rotor resistance. Okay, rotor resistance. So that's why lah in this question, okay, given stator to rotor turn ratio, ni adalah turn ratio, stator to rotor turn ratio is 2. So you have to bring the okay, the R at, which is at the stator side, to the rotor. Okay, so if you still remember, okay, how we bring the resistor from primary or secondary side, for example Z1, Z2, okay, from Z2, okay, we multiply by A squared, and then from Z1, okay, which is we want to bring from this primary to secondary side, we divide by A squared. So A ni adalah turn ratio. So given turn ratio is 2, so we can bring this R at on the rotor side. So R at rotor, okay, R at equals to 0. Okay, we have to divide by A squared. Okay, 0.14 divided by A is 2 squared. Okay, so you can get the answer is 0.035 ohm. So this is the R at in series with rotor resistance. Thank you.